Hello, everybody. We're on the next tutorial, which is on circle theory. As you can see, I arranged the subtopics so that it will be easier for us to learn. Before we go over to the main theorems, which is the main circle theorems, we need to revise our basic theorems here under the subheading corresponding angle, alternate angle theorem, consecutive angle theorem, vertical angle theorem, angle sum theory for triangles, stereo angle theorem, isosceles triangle theorem, radius tangent relationship. So we need to be good at this. It will help us to solve the main theorems, to solve questions using the main theorems. So let's revise. Let's go over to the basic theory. So the first, so assuming you have, there's the basic theorems. You have two parallel lines, and you have a transversal. A transversal is just a line that intersects two or more parallel lines. So once we have a transversal, some couple of angles are formed. So let's label this A, B, C, D. While this one is E, F, G, and H. So from the first category of angle we are going to look at is corresponding angle. Corresponding angle theorem. So it's just direct from here. This is a parallel line. This is also another parallel line. So on the same side, A is like E. So we are saying that A equals E. That's based on corresponding angle theorem. So the next one is B equals F. Y, C equals H. Finally, D equals G. So that's our corresponding angle theorem. So the next one is alternate angle theorem. So alternate angle theorem states that if you are given two parallel lines with a transversal, that C, look at this, at different side of the transversal, C must be equal to F. So C must be equal to F. Y, D must be equal to E. So these ones are the alternate interior angle theorem. This one is alternate interior angles. So we still have alternate exterior angle, which is A. Which is A equals G. And B equals H. So these are the alternate exterior angles. So that's the two. So the next one is consecutive angle. Consecutive angle theory. So consecutive angle theorem, or you call it allied angle, is just on the same, this is the transversal. If you see this transversal, C, on the same side, C and E lies on the same side. So the sum of the two angles there must be equal to 180. So that's the first one. While the second one is D and F. So D plus F is 180. So the other one is vertical angle theorem. vertical angle theorem. So that's just once you are given, if you are given any intersected, whether they are parallel or not, once there is an intersection, vertical angles must be formed. So we are saying that A must be equal to D, B must be equal to C, E must be equal to G, F must be equal to H. That's our vertical angle theorems. So the next basic theorem we are going to look at is the next basic theorem is the angle sum theorem. We also conversant with it. We've been using it. It's just that it states that the sum of the interior angle of a triangle is 1/8. So we're going to angle sum theorem for triangles. So it states that if you are given any triangle, that the sum of the interior angle is 1/8. So we are saying that A plus B plus C must be 1/8. So that's what the angle sum theory states for triangle. So the next one is exterior angle theorem. They are all based on triangle. So the other two, exterior angle theorem and isosceles triangle theorem, are all basic triangle theorems. So let's look at it. So the next is exterior angle theorem. So from the name exterior angle is formed when you extend one of the sides of a triangle. So this is an exterior angle. Let's call it A. So why the other two? So the other two triangle angles that doesn't form a linear pair with A. Linear pair, that is angle on a straight line. The other two angles, apart from the one that forms a linear pair with A, is called the remote interior. So we are saying that B and C are the remote interior. B and C are the remote. These are remote interior angles. So it states that the sum of the remote interior angle of a triangle equals the exterior angle. So we are saying that A equals B plus C. That is our exterior angle theory. So the next one is isosceles triangle theorem. So from the name isosceles triangle, so the theorem is restricted only for isosceles triangle. And you know that isosceles triangles, the base angle are congruent. So it states that the base angle of any isosceles triangle, so assume these are the two sides that are congruent, that the base angle are the same, that they are congruent. So if you have x here, this should be x. So the base angle, they are the same. So that's our exterior, that's our isosceles triangle theorem. So the next one is, the next theorem is radius tangent relationship. So this one is for a circle. So it's for a circle. It's just that if you have a circle and you have a tangent, sorry. So if you have a circle, I have a tangent line. So a circle of, assume this is the center of the circle, let's call it a 0. Let's call it O, center O. So, and you know that the distance from the center to any part of the circumference of the circle, the distance from the center to any part of the circumference is the radius of the circle. So this is the radius. Let's use R for the radius. Why this is the tangent line? A line that intersects a circle in only one point. So it's just that is a theorem. It states that the angle made by the tangent line and the radius of the same circle is always 90. So this is 90 degrees. So once you see a circle and a tangent line, know that the radius must make an angle 90 with the tangent line. So that's our basic theorem. So let's go over to the main theorem. So the first theorem is, but before then there's what we call an inscribed angle. An inscribed angle. So if you have a circle, so if you have a circle and a line from the circumference, that's a chord, two chords, chord 1 and chord 2 that intersect on the same point on the circumference of a circle. So the angle formed there is called the inscribed angle. So we are saying that this is the inscribed angle. So why the arc? Let me label it this arc AB. So why the arc here is called the intercepted arc. So this is called the intercepted arc. So that's the basis. So we now go over to the main theorem, which is called the inscribed angle theorem. So the first theorem, inscribed angle theorem. The inscribed angle theorem. So it has something to do with the inscribed angle. So if you have a circle and you have an intersected arc, it states that the angle formed at the center is twice the intersected, it's twice the inscribed angle. So I'm saying that if this is the center, so if the inscribed angle is theta, that whatever that is here, that is the central angle here, must be 2 theta. So that's the theorem. It states that the angle at the center, is twice the inscribed angle. So that's the theorem. So the next, okay, let me show you why. Let me do a quick proof. So that's a quick proof on. So if you have, that's what we are given. And this is the center. And this is the center. So center O. This is center O. So let me partition this. So let me draw an auxiliary line to the center. So you know this is the radius of, if R is the radius, this is also the radius. Also here, radius. So the base will form two isosceles triangles. So assuming here is theta. Here is also theta. Why assuming here is beta? Here is also beta, based on isosceles triangle theorem. So if we extend the line, we form an exterior angle. And using exterior angle theorem, that the angle at the center is twice the angle, the exterior angle of a triangle is the sum of the two remote interior angles. So we are saying that here now is theta. Here is 2 theta. Theta plus theta, which is 2 theta. Also here, that's 2 theta. So here is also 2 beta. So remember this angle, the inscribed angle here is theta. This is theta plus beta. So why the central angle here is now 2 theta plus 2 beta, which is 2 times theta plus. So which is correct? Whatever that is here is 2 times there. So that's our proof. So let's go over to the second theory, which is Bohr's theorem, or angle in the same segment. So the next theorem is Bohr's theorem. Okay. So let me give a quick example to illustrate this theorem. So example. So assuming you are given a circle, this is a circle. With center O. And here we are given x plus 10. We are given 3x here. We are asked to find the value of x. So without wasting time, the value is simple. So using inscribed angle theorem. So the answer is direct. So the solution. So by inscribed angle theory, which says that the angle at the center. So which says that 3x, that's the angle at the center, must be 2 times the inscribed angle. So that's inscribed by inscribed angle theory. Remember this is geometry, so always back your solution with its correct theory. So expand the bracket, 2x plus 20. So find this 3x. Therefore, 3x minus 2x. 3x minus 2x is 20, which implies that x is 20. So that's the answer. So whenever you are given anything and you are asked that you are given the central angle, so what will come to your mind is to use inscribed angle. Again, there is an additional theorem that will help us to solve a lot of questions fast with inscribed angle. So assuming this question 2. So assuming this is a circle with Assuming this is the center. This is the center O. So we are asked to find the relationship between X and Y. So we are asked to find the relationship between X and Y. So the solution is direct. The solution is that let me get a different ink. So for us to solve this is very simple. Since this is the center of the circle, we know that here must be 2x based on inscribed angle theorem, and we know that here must be y based on isosceles triangle theorem, and we know that we form a triangle. We have triangle O. So in triangle OAB, from angle sum theory for triangle, that y plus 2x plus y must give us 1/8. So y plus y is 2y. So we bring out 2x plus y equals 180. Dividing both sides by 2, x plus y equals 90 degrees. So that's the relationship. So whenever you are asked to solve this kind of question now, look at this. Assuming you are asked to solve this, they are given this. They told us that this is the center, and we are given 30 degrees. And we are asked to find x. So without wasting time, the answer is 60 based on what we've solved. So you don't need to waste your time. So therefore, x is 90 minus 30, which is 60. So this is a very nice theorem. It's an additional theorem. And it will now tell you that whatever that is here, the sum, whatever that is here must not be up more than 90. The inscribed angle must not be more than 90. That's the meaning. It's not possible to be more than 90. So it helps us to show that the inscribed angle should not be more than 90. And the sum should not be more than 90. So that's it. So we move to the next theorem.